Welcome, or hopefully welcome back to another episode of the Reliability Matters podcast. For those of you who continue to count, this is episode number 132. Today, we'll take a deep dive into the world of conformal coating. More and more assemblies are being subjected to conformal coating to protect the assembly from harsh environments. What's leading the drive to conformal coat electronic assemblies? What types of conformal coating options are available? What are the advantages and disadvantages of each type? For circuit assemblies, the protective embrace of conformal coatings ensures reliability, longevity, and performance. As technologies advance, so does the demand for innovative solutions to safeguard our electronic products. Whether you're a seasoned industry professional, a curious tech enthusiast, or just someone who's new to the world of conformal coating, this episode is your go-to source for in-depth information on the growing trend of applying conformal coating to circuit assemblies. So join us as we peel back the layers and immerse ourselves in the world of electronics protection and learn how conformal coatings play a pivotal role in keeping our devices humming, even in the harshest environments. To better understand conformal coating, I invited Lisa Rizzo to the show. Lisa is Senior Director of Strategy and Emerging Applications at HZO. HZO is a global leader and innovator in protective solutions that, according to them, keep the world running. They provide products to markets including consumer electronics as well as high reliability markets, including automotive, industrial, medical, and IoT, to deliver more resilient, reliable, and a durable level of protection. HZO specializes in nano-coating solutions that safeguard electronics, electrical products, and critical applications in an ever-changing market. So, welcome again to the Reliability Matters podcast. We'll take a deep dive into the world of conformal coating when I return in just a moment.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Thanks for having me. I appreciate you.
Well, I appreciate you being here. Before we get started with the really exciting stuff, let's just kind of go off track a little bit. Tell me something about yourself that might come as a surprise to your colleagues and maybe even some of your friends. Let's get the audience to know you a little bit better.
I had to think about this one, and I'd love to tell you that I alligator wrestle on the side or do
all my guests do that.
No, I don't do that. But one of the things that if only a few people know about is that I'm a yoga teacher for fun. Obviously, my full-time job is here at HZO, but I have completed my 200-hour and my 300-hour yoga teacher training. I finished, so I'm actually a registered yoga teacher for 500 hours. And besides teaching at yoga studios, I actually help out with some of the senior community where I live in Burlington, North Carolina. So I work with a lot of people that have, healthcare issues and injuries and things like that. And we try to stretch it out over the weekend. And I just work with them to make sure that they have better mobility in their lives and that it's a lot easier for them to get around.
Interesting. So the fact that this is kind of a little known fact means you don't show up to work with your yoga mats and try and get yoga recruits. You're not the yoga instructor over lunch or anything like that.
No. In fact, they do where we work in the industrial park. They actually have yoga teachers that come in and teach in the kind of the lounge area for the different buildings here. And I never tell them that I teach yoga. I just go in and take class and I'm in the judge-free zone. I'm just trying to practice and get my practice in a little bit. So yeah, I keep it. That's a secret I keep in my back pocket.
Oh, very good. Yeah. It's probably best to not let people know. Like if you're a waiter or a waitress, you go to a restaurant, you don't tell them you are. If you're a flight attendant, you tend not to tell them you are, because you can sit and observe from a common perspective, right? What
exactly.
How good they are or not. Before we get too deep into the technical questions again, regarding conformal coating, tell me a little bit about yourself. How did you find yourself in this strange world of protecting circuit assemblies? And, how'd you get here?
Sure. So I've spent most of my career in product management. So I've worked on new product development for different companies in the consumer product space. I worked for Rubbermaid, and then also in the industrial space, I worked for United Technologies for 8 years. I've always worked in new product development and emerging technologies. But one day I actually got a call from a recruiter, and they started to tell me about an exciting opportunity that they had for a company that was going to be relocating from Utah to North Carolina. And I met with the recruiter, and then I met with a few people from HZO, and they really got me hooked into conformal coatings because, you know, literally almost everything you use in your day-to-day life, you want to have some protection on it. And I just saw the opportunity for myself and for the company to grow and expand. And I was actually North Carolina hire number 2 for HZO. So they moved, like I said, from Utah to Raleigh, North Carolina. And I've been here a little over 4 years, and I really love the industry. I love what we do. I get pretty passionate about our conformal coating technologies and all the opportunities we have to expand our markets. And also just with the new product development side, I work with a brilliant team of engineers and scientists. So I'm never the smartest one in the room, which is always nice. But yeah, I work with a lot of great people and that are really passionate and care about what they do too. So that's a little bit of how I got into working for HZO and getting into the conformal coating space.
Yeah, fascinating. I do think I'm quite biased. I've been in the electronic industry for 37 years. Considering I'm only 27 years old, I must have started in utero. But yeah, we can. Hey, we make technology. We can break the rules. But what I find fascinating about our industry isn't so much the subset sections of our industry, the coating, the cleaning, the placement, the printing, whatever. It's the fact that we build cool stuff. Our industry builds everything everyone uses every day. Even in the most remote parts of the world, there's some technology out there. And sometimes when, I have a factory where, we build assembly equipment. And, I sometimes have to remind all of our team members that, your job is not putting a screw into a hole or putting nails in a crate. Your job is you're part of building something that runs the world, right? I mean, look around you. I dare you to find something, find no electronics within 30 feet of you or maybe 10 feet of you. There's always something there. And our industry built that, right? And your world and my world coincide in that we don't build products that make things. We build products that make things more reliable. And and there's some, I don't know, there's some value there. I feel good sometimes, when I'm like, what do we do? Well, my friends will never see what I build at the store, they don't have a clue what we do, but I can just tell people we make everything that you use that plugs into the wall or has a battery, we make it work more reliably. And you can thank me later, right? Not that we get that, but that's too deep down the rabbit hole for most civilian type people. So Rubbermaid, there's a name that you used to work for Rubbermaid. Are they still around in one form?
They are. They've actually merged they've bought other companies, acquired other companies. They continue to grow. And I used to manage their circular saw blade line, believe it or not, under the Irwin brand. And the very cool part of managing saw blades is that they were at the time manufactured in New Zealand. So I got to go to New Zealand a couple times, which was just bonus.
Nice. Took one for the team there, right?
Yeah, exactly. Yeah, it was really tough to twist my arm to get me to go there, but I really lucked out in that respect. But working for a consumer products company really helps give you a sense of urgency, especially when it comes to new product development, because it's really evolve or die. So we were constantly coming out with new products, which made it exciting. You had to stay pretty light on your toes because consumer products are definitely an aggressive sort of environment to work in. But I really enjoyed my time there.
Yeah. Let's talk about HZO briefly, just to put all of our conversation in context. if you've watched any of my shows or listened to any of my shows, you always know I'm fascinated by company names and the meaning behind them. Particularly when they're curious, right? HZO is a curious name for me. There's got to be some meaning behind that. So how did HZO get its name? What does all that mean?
Well, it's a takeoff on H2O, the chemical compound for a water molecule. And when HZO first really began, our focus was really on protecting electronics from water. But we've really evolved to go beyond just protecting electronics and printed circuit boards from just water. We go well beyond to safeguard your products against harsh environments. But I wish there was a much bigger story to it, but it was really just a play on H2O. That's how we got to where we are today.
Oh, very good. So it wasn't some drunken night where someone hit the wrong key. No, it wasn't that.
Well, no, I can't say anybody's willing to fess up to that. It could have been, but
we'll leave that in the rumor stage. Yeah. I remember several years ago seeing someone speak on behalf of HZO at a conference or symposium or something. This was several years ago, and it was all about waterproofing, as I recall. So to your point, that seemed to be the original motivation. And then, of course, there's a lot more damaging things than just water out there. So you kind of fall into that whole protective category. And bring me and my audience up to speed with HZO. What types of products and services do you offer in a macro and a micro sense?
Sure. Well, the way we go to market, we offer solutions in kind of a two-pronged strategy. So our first strategy is that we sell coatings, obviously. We specialize in coatings as a service. We have centers of excellence here in Raleigh, North Carolina, where I'm based, and our research and development team, our finance, sales, and marketing are all based. But then we also have centers of excellence in Dongguan, China, Hanoi, Vietnam, and by the end of this year, we're going to have a coating center of excellence in Chihuahua, Mexico. But customers can ship parts to us to any of these locations, and they can get a thin film chemical vapor deposition, plasma enhanced chemical vapor deposition, or an atomic layer deposition coating on their parts. So that's one way we go to market. We also have what sets us apart a little bit from some other conformal coaters in the market is that we can offer to clients who have large scale production lines a factory model. So we can go into, especially in Asia where there's larger manufacturing plants for electronics, we can go into their contract manufacturing plants and get a small section of their factory floors, and we can set up our coating production lines, including masking and demasking, and we can have them take their parts, hand them over to us. We'll do our part of the process, and then we pass them back on to the next part of the production line, usually packaging and testing, and then the parts can get shipped out to customers. So factory model is a really innovative way to help service large-scale production lines. We also do some equipment sales and leasing, not as much as we do the factory model or the coating as a service model. But HZO we also offer solutions to our clients in the form of consulting and specifying materials and coating processes. So we have a really large team here that has a lot of experience to meet the material and market challenges for our clients. So we partner with those clients to perform different functions where we even will run experiments and tests. If they have a theory about a coating and something they want to try out, maybe a different dimer or a different material, we will do some coating, we'll do some testing, we'll provide technical support on proving the material out, and then we even can help our clients with equipment specification, and we can partner with them to design equipment for coating, for masking, and for demasking. So we've really evolved into offering a couple different services to our client base.
Within the coating world, the coating world is fairly wide with different types of coating, different types of materials. And you're in a little narrower section of that. But before we get into that, if you would, just so we can help put things in perspective, let's review the various types of conformal coating from what you guys do, which is ultra thin nano type coating, to more, I'll call it conventional. I don't know if that's really the proper term because I'm not sure which came out first. Yeah, could be you're the conventional, but I think the more broadly viewed, when someone says conformal coating, if they're not a super expert on it, I think most people probably at least think of the more legacy products, the acrylics and the silicones and things like that. Let's talk about conformal coating from a wider perspective, and then we can start narrowing it down. What types of materials are out there, and what are someone's choices when it comes to conformal coating?
Sure. Well, at a high level, traditional conformal coatings are really specially engineered polymeric film forming products that protect circuit boards and other kinds of electronics and devices really from harmful environments that can include everything from moisture to thermal shock to vibration or static and just different forms of contamination. So conformal coatings will actually coat an entire part or conform around that part, irregular landscapes that you're going to see on circuit boards and other devices. And what they'll do is they'll help increase the dielectric resistance, the operational integrity, and the reliability of the part or parts that you're coating. And most of the traditional conformal coatings that we think of are acrylics and silicones, epoxies, urethanes, and then even parylene, which is really our wheelhouse. But, acrylics, those are very used in all of the traditional conformal coatings that I'm talking about today. They have multiple formulations out there. So there's lots of different flavors and varieties that you can get today. But, the traditional acrylics are a really, and acrylics and silicones and epoxies and urethanes, they're going to be liquid forms where parylenes and plasmas are going to be more of a dry coating process. But, acrylics are really great. They're a great low cost option for customers who are looking for a conformal coating that's going to be flexible and reworkable. Acrylics will definitely adhere to a wide range of substrate materials. You'll get good resistance against humidity and salt, and they have good dielectric strengths. So they definitely have a lot of pros. They can be a little bit limited in the solvent resistance and temperature resistance, and they can get a little tacky if they get exposed to higher temperatures. But they're a good low price option to use for conformal coatings. And then you get into more of your silicones, which a lot of people are very familiar with, and those are flexible and reworkable too. But they have a little better resistance to low and high temperatures. They don't absorb water. The only one of the downsides to using silicones is that they can outgas if they're not cured properly. They don't have a lot of abrasion resistance, and they tend to have lower tensile strengths. But again, you have to look for each manufacturer. They definitely have different formulations that you can look at that are going to offer different protection levels. And then, we don't see I don't see epoxies as much being used, but they do have really good abrasion and chemical resistance, and they have a little higher tensile strength than some of the other traditional conformal coatings. They can be a little tougher to rework because they can be a little more rigid and can have a tendency to crack under vibration. And they can also be used to encapsulate parts, not just as a conformal coating. And then you've got your polyurethanes. Those are going to typically have better chemical and abrasion resistance. But one of the downsides is that they can take a little bit of a longer time to cure, and they can be a little tougher to remove if you need to remove them in spots. And sometimes some of the formulations can yellow a little bit after time. But those are the typical traditional conformal coatings that a lot of people think of. And the nice thing about the liquids is that they can all be you can coat parts in either a batch process or more of an inline production process. And then there's the chemical vapor deposition coatings, which is really what our wheelhouse is. And what people most commonly think of is parylene. And parylene is a really good multi-purpose conformal coating. So it provides high levels of protection against submersion. So if you have an electronic device that needs a high ingress protection rating, that's where parylene comes in really handy. It's a uniform pinhole-free coating, and it can penetrate into really small spaces. So it's a good barrier. for corrosive chemicals and liquids and gases, and it has really good dielectric strength. But sometimes the challenge for Parylene is going to be that it's a batch process and it has a longer deposition time than what you're going to see with the liquid conformal coatings. So there's definitely trade-offs between the different conformal coatings that are out there, but that was kind of the 40,000 foot view of what they are.
Yeah, the press box view. So you mentioned that Parylene type conformal coating materials are done in a batch system. Is that because it's done under a vacuum? Therefore, it's really hard to have a conveyorized vacuum.
Correct. Yeah. So we use a vacuum. All of our chambers, whether it's CVD or PECVD or ALD, we have coating chambers. So the parts will get loaded into the chamber, and the deposition times, it's going to vary depending on how thick the film coating needs to be. So if you're going to have a coating that's a couple microns thick, it's not going to take nearly as long as something that's 20 or 30 microns thick. But it's also going to depend on what dimer you're using. So some dimers deposit faster than others, but typically you're going to see anywhere from a 6-hour to a 15-hour deposition time from start to finish, where with the liquid dispense coatings, it's going to be much shorter because it's that inline process.
Right. What, in your view, is driving the growth in conformal coating? I'm in the cleaning world, so cleaning and coating, the two C's tend to go together quite frequently. So, if there's a rise in cleaning, which there's clearly a rise in conformal coating as well. What do you think, from your perspective, is driving the need or the desire to coat?
Sure. Well, I think as we see electronics evolve, there's new developments all the time, and these products keep improving. If you compared a pair of earbuds or a smartphone today versus years ago, you're going to find out that those electronics have really advanced in their design and their fabrication method. And as we become more connected with these consumer electronics, and then everything, whether it's autonomous vehicles or interconnected health, you're seeing that these advancements in electronics are really forcing more miniaturization of electronics and printed circuit boards. And there's also a desire to really enhance the performance and the requirements for these circuit boards and electronics. So as the designers and the engineers have to keep developing smaller, thinner, more durable devices that are going to be used in a range of, low criticality all the way to high criticality applications, these devices, and also there's an expectation that the devices have to work sometimes, 10, 15, 20 years, especially in the medical space. Clients really want thin film coatings that are going to be high performers. So I think that's really some of the big driving factors to why people are looking towards conformal coatings, and they're also looking to really get chemistries that are going to produce high quality films that are going to be, thinner and thinner and thinner. We at HZO, we don't typically work beyond 50 microns thick of coatings, but we have customers that come to us that are looking for coatings that are 10 to 100 nanometers thick. So they've got design requirements where they've got a little bit of space. They can't have a lot of weight in thicker and heavier either encapsulation materials or enclosures or cases. So they're looking to thin film coatings to help support the requirements of the devices that they're working on.
You talk about the thickness within your space. Your vacuum deposition method is traditionally a much thinner coating than more spray-on liquid methods. Is that correct?
That's correct. I mean, with traditional conformal coatings, a lot of times you're going to see the applications in that 50 to 250 micron range. We don't do anything over 50 microns unless somebody has a very specific request.
So their bottom, their thinnest is your thickest, basically.
Correct. So, and now with atomic layer deposition and plasma enhanced chemical vapor deposition, we're doing coatings that are as thin as, like I said, 10 to 15 nanometers up to 1, 2, even 3 microns thick. So definitely a lot thinner than what we've seen in the past.
So this is a really kind of a common sense question, and I'm sure there is a technical answer to it. But logic would tell me that the thicker the coating, the more protection there is, right? Not knowing anything about the chemical process. So, and I know that's not true, but I don't know why that's not true. So explain to me and my audience, mostly me, how a much considerably thinner coating material can provide more protection, or what advantages there to the thinner coating material relative to its protection value. Does that make sense?
Yeah, I'll definitely try to break it down. So it does really come down, honestly, to the chemistries, in my opinion. So, with Parylene, I'll start with Parylene. We have different variants of Parylene dimers. So we have the typical Parylene C or Parylene N that most of our customers see, and that's where we're going to use those coatings in the 10 to 25 micron range. We can go up or down, depending on what the customer needs. But the chemistry behind Parylene C and Parylene N, those polymers just happen to be more effective at, first of all, depositing really not just thin film coatings, but really pinhole-free, crevice-free layers that you don't have to worry about cracking or bending. They flex with the parts as they flex. So they provide a really uniform coating across the device. So first of all, from a chemistry perspective, you've got advantages to the different types of dimers you can use, or when you get into, the plasmas or the ALDs, you're going to deposit metal oxides or nitrides that are going to be more effective than some of those traditional conformal coatings, but also just the way they're deposited from a mechanical perspective. You've got these thin coatings that don't have areas where they're either pooling up too much with coating or the coating is too thin. And because of the conformality of the different CVD processes that we use, even if you have, we're always going to recommend that you send us product that's very clean, but even if the parts are not as clean as they should be, our coatings are going to actually conform even around that contaminant to really protect that whole surface. And then also a lot of, when it comes to deposition, it's not just the cleanliness of the substrate, but it's also what types of adhesion promoters that you're going to use to adhere the coating to the substrate. We have a lot of work that we've done that's proprietary for choosing what kind of, primers or adhesion promoters you're going to use on top of your substrate, because every substrate is going to behave differently. So, FR4 is not going to necessarily have a coating adhere to it the way an aluminum or a stainless steel is going to have a coating adhere to it. So there's different adhesion promoters out there that you can use that will help the chemistries bind better to the substrates themselves. So I hope I didn't go too far out there and but there's different reasons behind the chemistries, the way you can make those chemistries work and adhere to the substrates that will really impact why we can go so much thinner than some of the traditional coatings that are out there, and why we can get better performance levels out of them.
Excellent. I live in the cleaning world. So again, I can't remember if I said this off air or on air, but as Maslow said, if all you have is a hammer, you see everything as a nail. I see everything as dirty or clean. And every time I read a conformal coating material, instruction thing, it always says, clean your board, or it doesn't say clean your board. The substrate needs to be clean and dry for good adhesion. And when I go around the country and the world for that matter, speaking on the subject of cleaning, I always show this old television commercial from the 1960s. This guy named Earl Scheib, he was known for painting cars, and he would paint any car. Back in the day, he would paint any car, bumper to bumper, any color you wanted for $29.95. And he was just famous in the way he talked. And I won't try and mimic it, but it was like, I am Earl Scheib, I'll paint any car for $29.95. And I always wondered, how can you paint a car for $30? That's a lot of labor. There's material, there's whatever. And then I realized that, in some cases anyway, they didn't really do any surface preparation. They didn't prime, they didn't sand, they didn't clean, they didn't dry. You just kind of drove in and they sprayed the color. And good news was, if you had buyer's remorse, you picked the wrong color, don't worry about it. It'll probably peel off in a couple of weeks. It's all about surface prep. So I love to push that example when it comes to conformal coating, that you really need. It's all about surface energy and good adhesion. And then I can't tell you how many people will come back to me after I talk and go, we've been conformal coating over boards that have not been cleaned, reflowed with no clean flux for years. It's fine. It's fine. Even though that's not best practice, many people still say it's fine. What's your take on the importance of a clean and dry substrate? And what's your best advice for surface preparation?
Well, we always recommend to our clients that they clean their boards prior to sending them to us. And if they can't, then we will actually clean the boards for them. So just a little bit of a background, bare boards can have a couple different types of contaminants. I think sometimes people don't always think about this, but you can have everything from flux residue to etching salts to even just like grease from people. If they're not using, gloves and PPE, they're going to get grease and finger, just yuck, salts or oils onto the parts. So we always recommend that, circuit boards or even just other parts that customers send to us, we actually advise them that they should be clean. There's, we have written procedures of what we recommend, but in general, we recommend that they clean their boards with like a vapor degreasing solution or some kind of a sustainable cleaning fluid. They can use an aqueous wash and rinse cycle. But, we always recommend that they do use some kind of a cleaning process. The vapor degreasing process can use, a cleaning fluid that is going to immerse and, really envelop the part that it's trying to clean. And then we recommend that you dry it to remove any extra contaminants that could be on the board or the device that you're sending us. But we view it as a very important step prior to even putting any of the parts into our equipment. So, we have, like I said, a couple different processes that we recommend for cleaning boards and devices. But to us, even though Parylene can conform and can coat parts if they have some contamination on them, we really highly recommend and advise customers that they need to have their parts cleaned before any kind of conformal coating process takes place. So we view it as a very important part of the process. And sometimes we'll even have clients that reach out to us and we'll say, oh, we don't understand why this other coating that we're using isn't working. And then we'll get samples and we'll see how dirty the parts are. And we're like, well, you can't put perfume on a pig. I hope I'm allowed to say that, but you can't.
No, I think I think we should have posters that represent that sentiment, because it makes perfect sense.
Yeah. But yeah, it's a very important part to a recommendation to either have the client do it or we will clean the parts before we put them into our chamber. Because the other thing is we want to protect our equipment too. We don't want those contaminants inside, even though we have processes for maintenance in between each production run. We don't want our equipment to get contaminated either.
Yeah, and that's unique to your application method. If you're spraying on I guess it is and it isn't. I guess if you're spraying, traditionally a liquid, you want to make sure that it's sitting on something clean. Just like if you're baking cookies, you want a clean cookie sheet, right? You don't want something from months ago that hasn't been cleaned. But in your world, particularly, if that contaminant gets into the chamber, it can be cross-contaminated to another assembly, right?
Correct. Yep.
And how important is dryness of the assembly? And not just on the surface, but within the layers, if it's a multi-layer board. The instructions all say clean and dry. What do you guys mean by dry?
Well, we will actually, again, part of our process is we'll bake boards to drive out that moisture or parts before we put them into our chambers, because it'll just end up taking longer to deposit the films. Because as you're pulling your vacuum on the coating equipment, if there's moisture in the process and in the chamber, it's just going to take longer. And we already deal with wanting to have shorter deposition processing times. So having any moisture inside the chamber itself is just going to make it take a little bit longer for us to process the parts. So just in general, we will take all the precautions that we need to make sure that the parts that we're putting into our chambers are dry also.
If there's a failure in conformal coating, what are those failures attributed to, and what are the remedies or what are the mitigation techniques to prevent those failures? We talk about cleaning. That's a good one, right? If it's adhesion failure, but I'm sure there are other things that could relate to that as well.
Where we will sometimes, adhesion's a big issue, and again, that's why we've done a lot of work in developing different adhesion promoters, which we don't disclose. But we also have different adhesion promoter processes. But contaminants are a big issue. But the other, another issue we deal with is if parts are, they need to be properly, in a lot, especially with circuit boards, they have to be properly masked and demasked. So if we have coatings that have gotten into areas that they shouldn't, that can become an issue. If there isn't coating in the spots where we need it, that's where you're usually going to run into defects. That's where you can run into issues with shorting. You can run into issues with corrosion attacking certain parts of the boards if they haven't been masked and demasked properly. But I would also say that you can run into issues with coatings where just they will delaminate if they haven't been properly applied. So those are really kind of the biggest issues that we will deal with. And I think it's probably pretty similar when you're looking at using, traditional liquid coatings also.
Yeah. What safety precautions or environmental precautions does one need to consider when they are maybe bringing in-house a conformal coating process, whether it's factory in a factory, as in your model, or setting up a conformal coating booth and spraying the smelly stuff on onto their boards? What are the safety and environmental factors that one really needs to know of in advance?
I really think the biggest challenges and the issues that clients have to be aware of is proper ventilation. So, because you're going to be working with, I almost don't care what chemistries you're working with, you do have to make sure you have the proper procedures in place to adequately vent the chemistries, the solvents. If you're working with solvents, you have to be able to vent all of those materials, out of the area that you're working in. You definitely have to have the proper PPE or personal protective equipment. I think that's a big issue. I used to work, and the reason I stress this is because before I worked for Rubbermaid, I used to work for a company that made safety gloves and respirators and eyewear. So that's a particular sticking point for me. But you have to make sure people are wearing the proper PPE and they know how to use it. So if they have to have respirators, that they're using the proper respirator, that they have the proper gloves that are going to, not just because you throw a pair of gloves on, it doesn't mean it's going to protect you from every chemistry that's out there. So making sure you have your safety data sheets for the chemicals that you're going to be working with, and you have the proper PPE equipment to use is going to be just as important as having proper ventilation, especially with the liquid conformal coatings. Our process, like I said before, is a dry process, so you still have to have PPE on, but our systems will properly vent any of the chemistries away. And so we take care of that, but that's a big issue. And just having your employees trained on how to even put the PPE on correctly I think is really important. I've seen all kinds of things out there from the years that I spent in the safety industry that I'm a big fan of training, and then a little bit more training.
Yeah. I think all of us have had experience through the COVID madness of watching people. We can argue whether masks are truly effective or not. There are people on both sides of that debate. Either way, whether they are or are not effective, when people are wearing them as chin diapers, as South Park called it, more than face masks, then clearly, if they were effective, they are not effective in that environment, right? So you're right. It's the application of that, how to use it. Just having one in your pocket doesn't make you any safer.
Exactly.
When it comes to rework, rework is kind of one of the dark arts in our industry, right? There's science involved, but it also is an artisan thing. You have to know what you're doing. One of the challenges, I do a lot of speaking around the country on the subject of cleaning, and therefore I'm around people who talk about coating, like yourself. Mm-hmm. And everyone talks about the application of conformal coating. And very few people talk about reworking conformal coating, because that's kind of it's not easy. It's not sexy. It's not, it's dissolve it in a super strong solvent or blast it off with, whatever, CO2 or whatever they're using, or whatever they use as a medium. But it's not a push button, pull a part off, put a part on, and recoat it. It's a dirty process from the rework standpoint. Are there materials that are more easily reworked, more difficult to rework? How does the materials that your company uses stack up in the level of difficulty or ease to rework?
Well, first of all, I have to get this plug in because there is a misconception around Parylene that you can't rework it. So that's a sticking point for me. But I do want to assure everybody that Parylene, while it's not the easiest coating to rework, it can be reworked. We recommend, if you need to remove Parylene from a board or a device, that you remove it. You can use different abrasion techniques. There's thermal methods out there. Depending on how much rework you have to do, you can do laser ablation, and you can even solder through the material, but it can be reworked. And I can speak more to Parylene because we don't. We will use liquid conformal coatings as maybe a secondary backup, a supplement to like a touch-up if we have to do it. So we don't typically work with reworking liquid conformal coatings, but I can tell you that Parylene, once you remove it, you can reapply some Parylene either in the entire area. You can recoat the part, or you can reapply it just in a specific area, or you can just use a spot touch-up of a supplemental conformal coating. Mm-hmm. But it's actually it's not as hard as everybody thinks it is to remove. But then, with liquid conformal coatings, they typically will have a remover that you can use to get those coatings off. And but I also do like to stress with Parylene in particular, there aren't solvents out there. Well, there's very harsh solvents out there. You can probably use like a THF to get rid of Parylene. But the advantage to Parylene is that it does provide such excellent protection against a wide range of corrosive chemicals and liquids. So because it's so great at protecting the part, that's why it's so hard to remove it.
Yeah, exactly. I was just thinking that the benefit, on one hand, protection, makes it, it's expectedly more difficult. That's logical, right? If it came off with soap and water, it wouldn't be a good protectant, to begin with. So you kind of buy one advantage and get a little bit of a disadvantage. But, again, what's more important? The keeping a part safe or being able to, tear it apart later and fix it. I think everyone would agree the former is more important. Both are important. The former is probably more critical, mission critical. What types of companies? No, let me change that. what types of products in your world do you find better suited for parylene and vacuum deposition models as opposed to just spray-on liquids? What would drive someone to that conclusion? Let's just leave it there. What is there a particular type of industry that tends to just knee-jerk toward that technology or an alternate technology, or is it really very application specific?
It's going to come down to a couple of different factors. So the application for the part is going to be really important. The longevity of the part. If you have a circuit board that's going to be in service for, 10, 15, 20 years, parylene makes a lot of sense because it's going to hold up over long periods of time. I mean, we have parylene applications where the devices have been in service for over 20 years. Parylene has a very long history. Even before HZO, parylene has been used since the late 50s and 60s to coat medical devices, aerospace devices. So it's got a long history of performance in high critical applications. So if you do have a high critical application where, whether it's aerospace or military and defense or medical applications, parylene is a really good fit because we know it's going to perform. We know parylene is biocompatible, so it can be used in medical devices. So it's going to lend itself to those types of applications. If you have even with more, I guess, cheaper consumer electronics devices, I'll use e-readers as an example because that's something we have a lot of experience with. That an e-reader doesn't cost a lot of money, but people don't like to have to replace those. And you would not believe how many people actually take e-readers and sit in the bathtub and will be, reading their book. And then if they drop that e-reader, if the board has been protected with parylene, you're going to be able to take it out of that bathtub and you're going to be able to shake the water off, and then you can still keep using the device. So the application is going to be really important, and that'll even determine for parylene what flavor you might want to use, because while parylene C and parylene N are really good multi-purpose dimers, there are applications where the device is going to be exposed to higher temperatures, ultraviolet light, and that's where there's other parylenes out there. When you start to look at parylene F, like the VT4s and the AF4s that are out there, those are going to be higher performing dimers, and those are going to be more suitable for some of those types of applications. So application is really important. What your constraints are going to be, if you have to have the parts coded internally to your facility. So a lot of aerospace and defense applications, they cannot send those parts out, whether it's because they're highly confidential or they just the cost. I've had government facilities call me to tell me that they have parts that are worth, tens and $20,000 each, and they're not going to ship them out and have them coated. So that may mean that they would either have to buy a parylene coater to install in their facility, or they might want to look towards using either a spray or a dip coating or selective spray liquid coating. So some of that is going to play into how you're going to determine which process and chemistry makes the most sense. But then also we have to be practical. Like, what is your budget? So what are the budget constraints? And what's the size of the parts that you're trying to coat, and how, what's the volume of the parts? So there's a lot of factors that play into why you may choose one over the other. We find that parylene definitely lends itself to high volume applications. That's why we've coated millions of devices, in the history of our company. But that being said, if you have a couple small parts, and we do deal with clients that just have, hey, I've got 10 or 20 parts that I need a conformal coating on, I can ship them to you, so you can do coating as a service. Well, parylene is going to lend itself to that too. So I don't want to say parylene is going to be awesome for everybody, but it can check a lot of boxes. And, that's why we've been successful, and that's why our competitive set has been very successful with parylene too.
One little techie question here. I know that in the liquid worlds, sometimes you'll get a UV tracer so one can see where the conformal coating is being applied, particularly if you're applying it manually. Is that a thing in a vacuum deposition world? Obviously, it's not being applied manually in that environment, but is it important to be able to physically see the conformal coating after it's coated for inspection purposes?
That is a question that comes up every so often. Most of our clients that come to us do want a transparent coating that they can see through to see to their devices. So we don't typically use any kind of tracers, and we don't use color either. We actually get requests every so often from a customer that wants a green. They want the coating to have a color to it, and we don't. Like while we like to help all of our customers, we don't get involved so much with the coloring and stuff like that. But we do have access to materials that we can put into the coating. So there is a tracer. We just, I think I can count on less than one hand how many times we've actually done that. So it is possible. We just don't do it typically.
Right. In the world of coating over assemblies which contain LEDs, I've read papers in the past that talk about certain types of coatings will discolor over time. I think you referred to some of the yellowing of some of them, and that could alter, the amount of lumens that emit from the diode or the color of that. Is that a thing is that a concern in a vacuum deposition model, like a Parylene model? Is that discoloring possible? I would think it's so thin that there's not a lot of discoloring to happen, but tell me more about that.
It can happen with, you can get yellowing of a Parylene C or an N coating. So that's where you're going to, we recommend looking towards the higher performing Parylene dimers, and that's where you get into more of that Parylene F. There's two flavors that we work with of Parylene F. It's VT4 and then AF4. And especially when you get into the AF4, which is a very high performing dimer, that is where you're not going to see that discoloration if you're exposed to, a lot of UV light. So there's options out there. But then you have to look at how practical it is. Like if you've got these big outdoor LED displays, how practical it is to try to use a chemical vapor deposition process with those dimers on parts that are going to be so big. So that's where sometimes more of the traditional conformal coatings are going to be more typically used.
Since the process your company specializes in is a batch process, has to go into a chamber, is there a maximum size chamber? Or do you guys make custom chambers for unusual applications? Or how does that work if someone has a large format, large footprint assembly?
Well, our Pro 750 machine, which is, if you look on our website, that's the piece of equipment that we use the most. That's got a meter. That chamber itself, coating chamber, is a meter cubed, and we develop different fixtures and racking to go inside that chamber to hold different parts. So if you've got a couple really large parts, they can fit into that chamber. Or if you have lots of really small parts, we can develop fixtures to hold those parts inside that chamber. But as far as CVD equipment for Parylene, that's our chambers are the biggest ones in the industry that we know of. We have smaller coating chambers, even here in Raleigh, that we have smaller chambers that we'll use to coat like smaller runs, or when we get into using some of these more expensive dimers like Parylene Fs, we will use the smaller chambers for that. If we have a client that has a specific request, we can develop smaller chambers for them. There is some existing equipment out there from other people that if they are only looking for like one machine and it's for like a university or something like that, we'll probably recommend that they buy somebody else's equipment. But if there's an opportunity where they need us to look at reconfiguring a chamber, we can do it. But like I said, we also try to take into account if it's just a one-time request, then if we can point them in somebody else's direction, we'll do that. But we do have a lot of options because our chambers are so large. We can coat a lot of large parts. The only thing we can't do is every so often I'll get a call from somebody who's like, I've got a 10-foot pipe here that I need coated. Can you guys do that for us? And yeah, that's a little out of our that's a little out of our wheelhouse. So that's going to be sorry, we can't help you with that. But stay tuned, down the road, I think you're going to see more and more product development out there where there will be ways to coat larger, longer parts with parallel. It'll just be different application methods.
Yeah. So you kind of gave me the perfect segue to my last question, which is get out your crystal ball, Lisa. And, without giving away any proprietary secrets, I don't mean this in a HZO sense, but in a larger industry sense. Where do you see the future of conformal coating from a technology standpoint, from an application standpoint, from market share, not market share with HZO, but, how many more people or fewer people will be doing conformal coating as time marches on based on the trajectory you see today?
Sure. I believe that coating materials are going to continue to evolve, and with the chemistries that are out there and that are getting developed, we're going to see more and more options out there for lighter, thinner, high-performing coatings. And I think we're going to see a lot of advanced techniques out there. So I think we're going to go well beyond the brushing and the dipping and the spraying and get into, more advancements in vacuum deposition. I think we're going to see people leaning more towards using not just paralleling, but also atomic layer deposition, where it's going to be nanometer thin coatings of oxides, metal oxides and nitrides, where they're going to stack layers of different thin films to get different performance characteristics, lower water vapor transmission rates, but also excellent chemical barriers and different levels of protection. So I think you're going to see a lot of advancements on the vapor deposition side. I think you're going to see, as more and more people learn about some of these processes and there starts to be more demand for it, you're going to see more process development where you're going to be able to use, single reactors to do multiple types of deposition. I think that's going to be here a lot sooner than we think, and it doesn't exist already with some manufacturers. But I think people are going to really start to lean towards these, nano coatings, much thinner coatings. And I think they're going to use them. I think we're going to get further and further away from encapsulation materials and more into just coating the base parts. And I think because a lot of the encapsulation materials are using, materials that aren't so environmentally friendly. So I think, there's going to be this constant push to get away from chemistries that have PFOAs and PFOSs. People are going to want to use halogen-free alternatives. It's going to be a push to get, meaner and greener with the coatings that are going to be out there and available.
Well, very good. Well, thank you, Lisa Rizzo, for being my guest today. Thanks for enlightening me and hopefully my audience on the ins and outs of ultra-thin coating in particular. And thanks for putting that part of the market in perspective for me and my audience. If my audience has any questions specifically for you, is it okay to share your contact information in our show notes?
Of course. Thank you.
All right. Be careful what you say because your mailbox will be overflowing. So for my listeners and viewers, if you're listening to this or watching this and you have more questions for Lisa on the subject of conformal coating or yoga, for that matter. For those of you who tuned in late, they're going to go, what's he talking about, yoga? You have to watch the beginning. Just look at the show notes. When you're safely pulled over from your car, go to your podcast app and look at show notes, and you'll see Lisa's contact information as well as the company information. And if you're watching this on YouTube, right down here somewhere, there's a little button that says show more. Click that, and you can read the show notes there as well. And that will also have Lisa's contact information. So Lisa, thank you for spending the last a little over an hour with me and my audience. I really appreciate your knowledge and your willingness to share it with me and my audience.
Great. Thank you, everybody.
Well, that's another episode. Thank you for listening to or watching the Reliability Matters podcast. Be sure to subscribe to the podcast on your favorite podcast app. Or if you're watching this on YouTube, be sure to click the like, subscribe, and bell icons to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. A special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks again for being part of our podcast family. Stay safe, stay healthy, stay happy, and perhaps most importantly, keep doing it right. And I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.